Thanks very much. Hello, everyone. My name is Paul Murphy. I'm the CEO of a company called Clarify. And with me is Eva Rothschild, who is our VP of R&D. If any of you have really technical questions, you should find us upstairs. It's very rare that I can ever get Evo to come to any kind of conference. So take advantage of the fact that he's here. Now, normally, our head of marketing is around, and he likes to do these kinds of presentations. And we were very surprised when we came in this morning and discovered that the title of our talk was Don't Be a Smog or Smaug, or I don't even know how to pronounce it. He's the dragon and the hobbit. Reinvest. And at first we thought it was a joke, but it turned out that we just had never paid attention to what he told us. And so that's not the presentation that we prepared. We got together a few days ago and said, what are we going to talk to these fintech people about? And we put something together that had nothing to do with the dragon and the hobbit. But I'll tell you what our marketing guy wanted us to talk about. He wanted us to talk about the fact that in banks, compliance tends to collect all these recordings. They record their call centers, they record their traders, and they put them in a vault, and then they don't let the business people get to them. When in fact, the recordings are full of information that is useful and valuable. So with that sort of backdrop, what I'm going to do now is just walk you through some examples. Some of them are, so they're either things that are in development now, or they're things that are in production. Although you won't be seeing the actual production pieces because they're client confidential. So first of all, what is it that Clarify does? We take audio and video files, we ingest them via an API, and then we give developers the ability to search through their content or to just get raw data about the contents of those files. So the three examples I'm going to show you, one is in compliance, one is trend analysis, and then we're going to do something a little more generic, which is information discovery. So in compliance, the use case is relatively straightforward. The regulators are asking banks to record their trader conversations. The banks then have to retrieve those conversations when there's a regulatory request. Now, in the old days when they did this, they would just hire people to sit in a room and look for the relevant calls by listening to them. That's no longer okay. They have to be retrieved relatively quickly. In some cases, depending on the country, the law requires retrieval as short as 72 hours. And the only way you're going to be able to do that is if the calls are already pre-indexed, not only by metadata, but also by their content. So this is an example application that's very much like one that compliance officers are using now. And so this particular account has 3,800 recorded calls in it, 3,700 recorded calls. And if we wanted to find every call that mentioned the word gold, for example, Evo would just type it in, and then it would retrieve, in this case, 9 conversations that include the word gold. Now imagine that we're 90 and we wanted to refine it even more. We could add, let's say that we were interested in trades related to Austin, could add the word Austin. And then if Austin and gold were mentioned, you would get it down to these 3 conversations. And it's not just giving you three entire conversations to listen to, but we can actually open it up and actually go right to the spot in the call. So you don't have to listen to a 37-minute call if you just want to find the bit with the information that is potentially relevant. It may not be relevant at all to your problem. Was there anything else I want to show in that?
The metadata search?
Yeah, so along with the media, we also index the metadata. So in this case, it looks like if we wanted to narrow this down to calls in the 917 area code, you could just add that to the query, and then it would just turn up that one, well, maybe not. Oh, I see why. No, make it an 800 number. And so that'll get it down to just that 800 number that was called. The reason the last one showed all 3 is because the source number was in the 917 area code, so it just pulled all of them up. Okay, moving on from here, we're going to go to trend analysis, and so this is a case where you would look at keywords in conversations and look at the trend over time. So you could get a sense of what people were talking about over a period of time. And so this is just sort of a dramatic recreation because the project that we're working on is still very much in the works. But what Ivo's done here is he's taken real conversations, he's pulled keywords, put them into a spreadsheet, and then graphed those so that you can get a sense that the topic of conversations is changing over time. So where did this come from? It came from the head of a trading desk who had traders in 3 different locations and wanted to get a sense, and wants to get a sense, of what it is they're talking about. So he wants a 50,000-foot view into their conversations, so to see the keywords that are happening across his desk, and then be able to go down into the various locations so that he knows what his clients and his salespeople are talking about. And this is important because the data that they're trading on, a lot of that stuff actually appears in the phone calls before it appears in any kind of systems. So this is another way that our technology is being leveraged in fintech. And to do this is actually very, very easy with the API. So what Ivo's going to now show you what it takes to take one of these conversations, one of these calls, and index it. It's a single function call, and so that was it. And what you get back is a data structure that describes what was produced as a result of that call. And we use something called hypermedia, which means that we're returning JSON that includes references to related data directly in the JSON, and that makes it really easy for developers to be able to pull either dependent data or related data without having to construct URLs. So one of the things that that came back after we submitted that data was the fact that we had insights related to that audio file. Ivo just retrieved that particular reference, and what he got back was a list of insights. So he has classification insights, spoken words, and spoken keywords. So now if we retrieve the keywords, you'll see that in the file that we just indexed, you'll have to pull that up. So these are the kinds of words, gold, copper, oil, that were pulled out as keywords. And that's sort of the basis for the trend analysis that we just talked about. And it's the same sort of thing to do the search that I showed you at the very beginning. Okay, so from here we're going to move on to a much more generic example, but it's an example that we run into when in fintech as well, and that is people have audio and video files sitting around, and in a lot of cases they just can't find them. So this is an acute problem, obviously, in the media space. Anybody who produces media tends to have just terabytes of this stuff sitting around, and they know that things that they're interested in are there somewhere, and they'd like to be able to get to them. This particular example I was at a bank a few months ago, and I was showing it to a table full of people, and at the end of it, one of the guys tried to let his head drop against the table, and everybody sort of jumped up, and he said, you know, I wish I'd had this 2 days ago because I just spent the past week looking for a video clip in which our chairman was discussing Bitcoin. So his marketing department really wanted this video clip, and this poor guy spent an entire week looking through footage that belonged to the bank to find this particular clip. So this is the kind of thing that we run into a lot, and so in this particular example, an integrator. Our company's we're based in Austin, and an integrator in Austin decided to put this together for the clients of theirs. And what they've done is they've taken a generic video management, content management system, in this case it's Brightcove, put a bunch of TED videos into it, and then use our API to index those videos and then to search the content. So in the upper right-hand side, you'll see that we search for creativity, culture, motivation, and business. On the underneath that those are our results. Those are all the videos in which those words appear. And when we pick one, you'll see that underneath we have little indicators of where those words appear. And this particular interface lets you jump between them.
How the life of the world is, whether it be your business, your kind of therapy culture. Most of us don't do that. But if you're creative enough, playful enough, fun enough, build their own culture, how would they shape our culture? Background, no culture, no belief in reason.
So this is very useful for finding things very quickly. This particular use case is important to people in the education space in particular. And where does education come in banks? It's, of course, compliance training or any kind of training for that matter. When people want to revise, they don't necessarily want to go back and look at the whole thing. They just want to be able to look for the information that they were interested in. So there were two other things that I wanted to leave you with. One is that we don't just process in English. We also process in French and Spanish, and we're adding languages at a relatively rapid rate. So this is an interface that was put together for a French TV station. Same kind of thing. They had the manpower to create metadata around 2 hours of their daily content. They couldn't do any of their outtakes, and they couldn't do the other 22 hours of their broadcasts. And so we can do this for them very, very quickly, and actually far more accurately than humans can. And the last thing I wanted to show you is, as I said at the beginning, we're extracting data from audio and video. So far the examples I've given you are words. But of course, as the regulations right now only require conversations to be recorded, I don't know of any jurisdiction where video conferences have to be recorded, but that is something that regulators are definitely talking about. I know they're talking about it in England. And so people will want to also be able to analyze the video part of the video, the images, to be able to identify faces, to be able to identify signs or any kind of written information. And we've started down that path. We've started building our own image recognition system, and we've now combined it with speech. This isn't released yet, but it's something we will be releasing. And so in this particular example, we've combined the output from both those systems into a whole. And when Evo plays this, the first hit will be an audio hit, and the second will be visual. So in this case, we were looking for the word shark.
In the water, or that shark, or that fish.
There you go. So that's what I had to show you today. I know we have a few minutes for questions. Happy to take sort of technical questions or business model questions.
I need my computer. I have so many.
You have so many? Oh dear.
So the first one is, how well does this index musical videos? Musical videos.
So we aren't treating music right now. What we do is we detect music, and when we receive music, we reject it. Okay. Eventually, we plan on accepting music, classifying it. We've done some experiments because we have a client that's doing some work for Carnegie Hall, and they're interested in being able to classify their video by the kind of instruments that are played. So there are just many, many dimensions that we could look at, and a lot of this is essentially client-driven. So.
The next question is there a way to manually add metadata and keywords to the indexes?
Yes, there is. So our data structures, and this is something I should have mentioned, allow any kind of metadata to be associated with the media file. And that can be used, and it's also very tightly integrated in our search system. So you can use the metadata to filter. You can use the metadata as something that you search on. And some people have gone as far as associating timestamps with the metadata, and that allows you to build things like conferencing systems that include buttons. So you push the button when there's something really important. That gets injected into the data structure, and then when you do a retrieval, you can actually pull that piece of information along with the timestamp.
Okay. Another question was, could you give us some examples of using this technology in fintech and in banks?
So the compliance example was a real example that is in production at a tier 1 bank, and the second example I gave is something that we're working on right now.
Okay. Another one was some more people in the audience wanted some more use case examples. Could you talk to
More
me
use
about-
case examples.
Yeah.
Gosh, well, I have a pretty interesting one. We're working with a company that's doing a big project for the Air Force, and what they're doing is when AWACS, which are these big surveillance planes, land, they need to analyze data that was collected during the mission. The problem is that they can't analyze the data fast enough. There's so much of it. So what they want to do is they want to take the recordings that are made of the pilots. They want to index that as quickly as possible, find the important bits of the mission, and then use that to restrict the amount of data that they look at and analyze. So it's a pretty odd use case. So it's essentially using the timeline of audio to restrict the amount of data that's analyzed. Eventually, they'll analyze the whole thing, but in this case, I don't know, they dropped a bomb or they did something, important.
Excellent. All right. Does Clarify do real-time analysis for customer support use cases?
That's a question I get asked a lot, and we don't right now.
Okay. Let's see if I. Wow, you guys just keep going, don't you? What other languages do you have?
So we're doing Spanish and French, and we will be doing Italian and Brazilian Portuguese fairly soon. German is on the roadmap. We're also looking at Asian languages. We spend a fair bit of time out in Asia talking to people who are building language models for Asian languages.
Okay. All right, another one. Are you currently doing any sentiment analysis so that we can search by happy or angry, such that if those terms aren't used, but the caller's demeanor is like that, can we find it?
So there's two things when people talk about sentiment analysis. One is natural language processing. So basically taking the language and deciding whether what people said was positive or negative, and that's something that a lot of people are selling right now. The issue is that it's not terribly accurate. When you have humans read the same thing and give you a thumbs up or a thumbs down, and just in terms of positive or negative, we find that the automated algorithms are correct about 55% of the time, which is pretty close to flipping a coin. But there's another way to think about to analyze sentiment when you're dealing with audio, and that is just in intonation, and that's done. And you can do that in a completely language-independent way. And you can tell whether somebody is angry, excited, bored. So there are a few sort of base emotions. And we believe that by combining those two, we might be able to improve the accuracy of sentiment analysis done using either one of those techniques. So it's something we're looking at. We're not selling it yet.
Okay, excellent. What's the technology stack that powers this?
Oh gosh. Okay. So in terms of the API management, we're using Node.js. Our workflow system is Python based. When it comes to language and signal processing, there's really a bit of everything. There's some C++, there's some Java, there's some Fortran, you name it. It's just whatever these algorithms are developed in, and a lot of these things tend to stick around for a very, very long time. Once they work, scientists don't like to touch them.